Welcome everyone. In this video, I will talk about the concepts and problems related to rank of a matrix. So let's start. First of all, let us look at the definition. The rank of a matrix A, denoted by R or rank of A, or some people also denote it by rank of a matrix by row of A, is the order of largest non-zero minor of A. It means what? The rank of a matrix is the largest value of R for which there exists at least one R cross R submatrix of A whose determinant is not equal to 0. I will explain this definition through multiple examples. But before that, there are few remarks which I want to highlight, and these remarks will also be clear to you when I will be explaining through the examples. So for any M cross N matrix, rank will be less than the minimum value of M and N. Less than or equal to. So you can see here R is less than or equal to the minimum of M and N. For a square matrix of order N, if rank is equal to n, it means that determinant of A is not equal to 0, otherwise R is less than n. And rank of a null matrix is equal to 0. I am going to take examples and then I will come back to this definition again so that it will make sense to you. Suppose this matrix is given. Let me call this matrix A. So I want to talk about how to calculate the rank of this matrix using the definition that I have just discussed with you. So the definition is saying that it is the size of highest order non-zero minor. So if I look at this matrix itself can be considered as a submatrix of this matrix, right? So if I calculate the determinant of this matrix, then what will I get? Let me calculate the determinant. I will expand it about the first row. So 1, 4 into 5, 20, minus 2 into 6, 12, minus 2, 1 into 5 is 5, minus 2 into 2 is 4, then plus 3, and 1 into 6 is 6, minus 2 into 4 is equal to 8. So what will I get? I will get 20 minus 12 is equal to 8, minus 5 minus 4 is 1 and 2 into 1 is 2. 6 minus 8 is minus 2 and 3 into minus 2 is minus 6. So what we get is equal to 0. Now we saw that this 3 cross 3 order submatrix or the matrix itself has the determinant value 0. Now how do you get a submatrix of size 2 cross 2? So to get a submatrix of size 2 cross 2, you have to remove any of the row. For example, suppose I remove this row number 3, and I remove this column number 3. So what I get is a submatrix of size 2 cross 2. So I write 1, 2, 1, 4. And if I calculate the determinant value of this, what will be the determinant of this? Determinant will be 1 into 4. This 1 into 4 minus 2 into 1. So that is equal to 4 minus 2, which is not equal to 0. So it means what? It means that this matrix has a minor of order 2, or we can also say that this matrix has a submatrix of size 2 cross 2 whose determinant is not 0. So it means what? That it means that the rank of this matrix, if I call this rank of A, is equal to 2. If I ask you in general that how many submatrices of size 2 cross 2 will be there, so I have just got one of them. Similarly, I can get other 8 submatrices also. how many total such submatrices of size 2 cross 2 will be possible? Total 9 submatrices of size 2 cross 2 will be possible. Why? Because to get a submatrix there are 3 rows, so I can leave the 3 rows in 3 ways. Either I can leave the first row or the second row or the third row. Similarly, I can leave the first column or second column or third column. So there are 3 ways to leave the column and there are 3 ways to leave the rows. So total number of ways are 9. So 9 submatrices are possible. I am interested in finding one submatrix of size 2 cross 2 whose determinant is not equal to 0. So let us go back and check the definitions once again. So what is the definition? The rank of a matrix denoted by R is the order of largest non-zero minor. So we got a non-zero minor of size 2 cross 2, so its rank is 2. Let us take the next matrix example. If you look at this example, first of all, this matrix is a 2 cross 3 matrix. So one thing that I want to understand before I find the rank, that the remark 1 is saying that rank in this case will be less than or equal to minimum of m and n. So if I ask you what is the minimum of m and n, m is 2 and n is 3. So the minimum of 2 and 3 is equal to 2. So it means what? That for this matrix, if you allow me to call this matrix B, if I say a rank of B should be less than or equal to 2, it means what? It can't have rank 0 because 0 rank is possible only for a null matrix. So it means that rank of B may be either 1 or 2, which I don't know, which I have to find, right? I hope you got this point. The remark is saying that rank of the matrix should be less than or equal to minimum of m and n. What is m here? M is 2, n is 3. Minimum of m and n is 2. So the rank of this matrix should be less than or equal to 2. So less than or equal to 2 are 3 possibility, 0, 1 or 2. But 0 is not possible because this is not a null matrix. I hope you know the definition of a null matrix. A matrix is said to be a null matrix if all its elements are 0, but it has non-zero elements, so it is not a null matrix. Now how to find the rank? So I am going to find a submatrix of size 2 cross 2. So here there are 3 columns, and if I remove any of the column, I get a submatrix of size 2 cross 2. So I removed the third column. I got a submatrix 2, 3, 3, 5. And if I calculate its determinant value, its determinant is equal to 2 into 5, 2 into 5 minus 3 into 3 is equal to 10 minus 9, which is 1. So this is also not equal to 0. So we have got a submatrix of size 2 cross 2 of this matrix whose determinant is not equal to 0. So now the rank becomes 2. Its rank, maximum rank possible was 2, and we already have got a submatrix of size 2 cross 2, so its rank will be 2. And when I was removing the column 3, it was not that I have to remove column 3. I could have removed any row. My interest here is to find at least one submatrix. Other submatrices possible will be what? Other submatrices possible will be if you remove the second column. Sorry, I was talking the row. It is column. So if you remove the second column, it is 2, 3, 4, 7. So 2, 3, 4, 7. What is its determinant? Its determinant is 2 into 7, 14 minus 12. This is equal to 2, which is also not equal to 0. But I don't have to verify all of them. My interest is just to find one submatrix of size R whose determinant is not equal to 0. And here we have got a submatrix of size 2 whose determinant is not equal to 0. So its rank is 2. I hope it is clear up to now. Now let us take this example. This is a big example, and I am going to put some effort. Let me call this matrix as C. First of all, this is a 4 cross 4 matrix, so its rank should be less than or equal to 4, right? Now if I have to find the rank, first of all, what is the highest order sub matrix of this matrix is possible? Whose determinant I can calculate. So this is a 4 cross 4, so its sub matrix can be taken as the whole matrix. So first of all, I will calculate the determinant of this, and if I calculate the determinant of this and suppose it becomes 0, it means its rank can't be 4, right? So let me calculate this, and through this you will also understand that how to calculate the determinant of a 4 cross 4 matrix. So I am going to expand it about the row 1. So if I expand it about the row 1, I take the first element and I write the sub matrix, leave this row and leave this column. So I will get 1 1 4, I will get 5 1 10, I will get -1 1 and 1. Then 2, so 2 is coming in the first row and second column. So first row, I hope you know that when you will be expanding it, you will be multiplying the elements by -1 to the power I plus j, where I is the row in which that element is coming and j is the column in which that element is coming. So here 2 is coming in the first row and second column, so I need to multiply 2 by -1 to the power first row plus second column, that is -1 to the power 3, that is equal to -1. So I will write -2 and then I will leave this column and this row. So I will get 2 1 4 4 1 10 and then 1 1 and 1. And then the third element is 0, so no need to write because you know it will make everything 0. Fourth element is 3 and 3 is coming in the first row and fourth column, so -1 to the power first row plus fourth column 5, so that is also minus. So I will write -3 and here I will write this row I will leave, this column I will leave. So I will write 2 1 1 4 5 1 1 -1 and 1. Now expand it. So first 1, and I'm expanding this determinant, so expanding it about the first row. So 1 into 1 1 minus 10, then -1, this row gone, this column gone, 5 into 1 is 5 plus 10, and then plus 4, and this column gone, this row gone, so 5 plus 1 is 6, right? Now if you take the second one, so I will write -2, 2 into 1 minus 10, right? 2 into 1 minus 10, -1 into 4 minus 10, so -1 into 4 minus 10, and plus 4 into 4 minus 1, so 4 into 4 minus 1. And let us evaluate the third determinant. So 3 2 into 5 plus 1 -1 into 4 minus 1. I hope you know how to expand. And then plus 1 into -4 and -5. So doing the calculation now, and let me change the color for better visibility. So this will be like -9, 1 is multiplied, so I'm writing -9 -15 and plus 6 into 4 24, then -2 into -9 into 2, that is -18, and this will give me -6, so it will become +6, and 4 into 3 is 12, and then -3, 2 into 6 is 12, -3 -9. So you noticed it is -24 plus 24, so this is equal to 0. This is also equal to 0, so -2 into 0, and this is -3 into 0, so what we got is equal to 0. So if we are taking the whole matrix, its determinant is coming to be 0, right? Now the definition tells that we have to find the largest sub matrix of A whose determinant is not 0. So the next thing is that I am going to look for 3 cross 3 sub matrices and I am going to calculate their determinant. But one thing that I want to highlight here, and this is something that I want you to do. First of all, how many sub-matrices are possible here of size 3 cross 3? If you take this matrix, any of the row can be selected in 4 ways. Like there are 4 rows, so 1 2 3 4. So I can select one row in 4 way, and I can select a column also in 4 way. So in total, if I have to get a sub matrix, I have to remove one row and one column. So that can be done. So one row can be removed in 4 ways, and one column can also be removed in 4 ways. So there are total 16 ways possible. So it means that there are 16 sub matrices. I am writing 16 sub matrices of size 3 cross 3 are possible. I hope you got this point. Now I have a task for you. I am saying that you take all the 16 submatrices and calculate their determinant. I am making a claim, but you should not trust me. You should verify yourself. Calculate any submatrix of size 3 cross 3 and you will get the 0 determinant. I can calculate one of the values for you and I will show that you will get 0 determinant. I just want to show one of this value. So let me remove this part here so that I can create some space, and I calculate one submatrix of size 3 cross 3 and I want to show that its determinant will be equal to 0. So what I am going to do, I am going to leave this row, right, row number 1, and I am going to leave this column and I am going to calculate this submatrix determinant. So I will expand it about, now this is our submatrix, right? I am going to calculate its determinant. So 1, expanding about the first row, 1 minus 10 minus 1, and then 5 plus 10, 5 plus 10, and then minus 4, not minus 4, plus 4, and 5 plus 1, 5 plus 1. So what do we get? We get minus 9 from here, minus 15 from here, and 6 plus 6 into 4 is 24, which I got is equal to 0. So I just calculated one of the submatrix determinant and I got 0. Similarly, you calculate the determinant value of any 16 of the submatrices that are there. One I already calculated. You can calculate the remaining 15. I am making a claim that all the determinants will be equal to 0. And if you don't believe me, you should certainly check it just for your conviction by trying some of the submatrices. Okay. So if that is the case, means its rank can't be 3 also, because this determinant was 0, its rank was not 4. All submatrices of size 3 cross 3 is also going to have 0 determinant value. So its rank is not 4, its rank is not 3. Now I am going to take a 2 cross 2 submatrix. So suppose I take this 2 cross 2 submatrix and I calculate its determinant. So its determinant will be 1 into 1. So 1 into 1 minus 2 into 2, so that I get 1 minus 4, which is minus 3, not equal to 0. I don't care about other submatrices of size 2 cross 2 because I am looking for at least one submatrix. You see it is written, I am looking for at least one R cross R submatrix whose determinant is not 0, and here I have got one such submatrix whose determinant is not equal to 0. It means the rank of this C matrix, if I ask you what is rank of the matrix C, so the rank of this matrix C is equal to 2. I hope up to this it is very clear. So the determinant approach of calculating the rank of a matrix is not that very easy, because if the matrix is of size 3 cross 3 then it is okay, but if it is of higher size, you can see that calculating the determinant of all the possible values is going to be very difficult, right? So I will devise one different approach to find the rank of this matrix, and I would also suggest you that these two problems I have left for you to decide by using the technique that I have just discussed, and just to check whether you have understood it or not, decide what is the rank of this matrix. I am going to do one more problem so that and this I will leave for you as an exercise problem, right? So this is your exercise problem, so please do this. This I am going to do. So let me call this matrix A, and first of all this is a 3 cross 3 sub matrix, so I calculated the determinant of it. What is the determinant? 1, and minus 3 into minus 8 is 24, minus 24, then minus 3, and 1 minus 1 into minus 8 is 8, minus 4 into 2 is 8. Then I take minus 4, and minus 1 into 6 is minus 6, and plus 6. What we get is equal to 0. So it means the rank cannot be 3. Now can its rank be 2? So you can calculate any submatrix of size 2 and you will notice that that is also equal to 0. You just can see. Suppose I take this submatrix. Minus 3 plus 3, 0. If I take this submatrix, it will be how much? 12 minus 12, 0. You take this submatrix, the first row 1, 3 and 2, 6, this will also be 0. So all 9, and I am leaving this for you to verify. I am making this claim because if I will solve all of it, it will take a lot of time. So I am leaving this for you. All 9 submatrices of size 2 cross 2 will have 0 determinant. 0 determinant. You must verify it, right? So its rank cannot be 2 also. But since it is not a null matrix, we at least have one non-zero element, so its rank is equal to 1. So what is the rank of this matrix? Rank of this matrix is equal to 1. Please verify the things that I am leaving for you and find the rank of this matrix. But I am going to discuss an alternate approach to help you understand that finding the rank through an alternate method by using elementary row operation or column operation is very easy, but for understanding purpose you should know this determinant approach also. Okay, so let's move. I hope all of you know there is something known as elementary row and column operation. So what is the elementary row operation? That Ri can be exchanged with Rj, Ri can be replaced by k times Ri, and Ri can be replaced by Ri plus k times Rj. Similarly, we can also define elementary column operation. Ci can be replaced with Cj, Ci can be interchanged with Cj, Ci can be replaced by k times Ci, and Ci can be replaced by Ci plus k times Cj. Now since we know this elementary operation, I am going to define something which is very important, and this is something that you must certainly understand, that is known as echelon form of a matrix. So what is echelon form of a matrix? Let us read the definition first, and then I will explain through multiple example. An M cross N matrix is called a row echelon matrix, or in the row echelon form, if the following conditions are satisfied. And it is slightly bookish language, but I will explain in the layman approach also, so don't worry. If ith row contains all 0, then it is true for all the subsequent row. Means if in a matrix there is a row which is 0 row, then every row in that matrix which comes after that row should also be a 0 row. I hope it is clear to you that when I say a 0 row, by that what I mean that all element in that row should be 0. For example, if you take this matrix, this third row is a 0 row because every element in this row is 0. This is not a 0 row because here some of the elements are not equal to 0. Right. This is also not a 0 row because one of the element is not equal to 0. Right. So if in a matrix there is a 0 row, then all other rows which comes after that row should also be 0. Second requirement, if the ith and I plus 1th row are both non-zero row, right, then the initial non-zero entry of I plus 1th row appears in the latter column than that of ith row. So to understand this, let us see this examples that I have written here, and it is slightly confusing also, so understand this carefully. What they are saying? They are saying that if ith and I plus 1th row are both non-zero row, so suppose I say this is ith row, means first row. So what is the I plus 1th row? I plus 1th row is 1 plus 1, that is second row. So what is the first non-zero entry in I plus 1th row? In the second row, the first non-zero entry, which is also sometimes known as pivot element. So the pivot element or the first non-zero entry is coming in the second column. This is the second column, right? And this comes, and the first non-zero entry in the first row is coming in the first column. In the first column. So did you notice that the a second row non-zero entry is coming in a column which comes after the first column? What is the third pivot element, or what is the third non-zero entry in the third row? Or let me repeat my statement. The first non-zero entry in the third row, the first non-zero entry in the third row is 9. So this 9 is coming in the fourth column. So the first non-zero, or in the first row, the first non-zero element is coming in the first column. In the second row, the first non-zero element is coming in the second column, and in the third row, the first non-zero element is coming in the fourth column. So each of these column are coming after that, right? Let us take this example now. Look at the first row, right? So this is the first non-zero entry. So it is coming in the first column. So in the second row, if there is a non-zero entry, this should come in a column which comes after the first column. So after first column, how many columns are there? Second column, third column, and fourth column. So in the second row, there is a non-zero entry, and it is coming in these three columns. Means it can come in any of these three columns. So this is true here. If you look at this matrix here, the first non-zero entry is coming in the first column. The first non-zero entry in the second row is coming in the third column. So third column comes after the first column, so no problem. So this second condition is satisfied is in all the three matrices. Now what is the third condition? That rows containing all zeros occur only after all non-zero rows. So there is a zero row here, and this zero row is coming after the non-zero row. Here there are 3 zero rows, and each of them are coming after the first 2 rows, which are the non-zero row, right? So these three matrices are in row echelon form. Row echelon form, right? I write few more example. Suppose I write a matrix like this. Is it in row echelon form? It is not in row echelon form. Why? Because you see that first non-zero element, which is the pivot element in the first row, is coming in the first column. But if you see this element, which is in the or for example, if you look at this element, this is coming in the third column, no problem. But this element 4, which is coming in the third row, it can't come in the first 3 column, because in second row the first non-zero element is coming in the third column. So in third row, the first non-zero element cannot come in first, second, or third column. It can come only in those columns which comes after the third column. So it can come in fourth column, it can come in fifth column. So this is not in echelon form, right? I hope it is clear. In case if it is not, I am going to take 3-4 more quick examples for you to understand. So let me write some matrix examples. Suppose I write a matrix 0 0 0 1 2 1 3. Now the first non-zero entry here 1 2 3 4 is coming in the fourth column. So in the second row, there should not be a non-zero entry up to the fourth column. So the first four entries must be 0. The next the first non-zero entry must come in a column which comes after the fourth column. So first non-zero entry in the second row can come in second column, third column, or this column, or this column, that is fifth column, sixth column, or seventh column. So suppose I write this, right? Now if you look at the third row, and if you want to have a non-zero entry, then it cannot come in first, second, third, fourth, fifth, or sixth column. So it can come only in the last column. So I can write this. And if there is a 0 row, suppose I write a 0 row, so that 0 row should come in the bottom. In the bottom, if there is another 0 row, so that should also come in the bottom. It can't come not in any of the above rows. It can come only either in this row or this row. So this is also in echelon form. Okay. Now since we have understood the echelon form, I am going to give you a new definition of the rank of the matrix. And what is the new definition? That the number of non-zero rows in the row echelon form of a matrix A gives the rank of the matrix. So it means what? That if we have to find the rank of the matrix, what we need to do? We need to reduce the matrix in the row echelon form, and then by counting the number of non-zero row in the row echelon form, I can find the rank of the matrix. Okay. So the problem here is that how to reduce the matrix in row echelon form, and this is very important, because this will actually be very useful for you to find the rank. And to reduce the matrix in row echelon form, we have to use elementary row operation, right? So what is the process? Let me take this example first. So the process is that I will first of all go into the first row and look for the first non-zero entry. So if I go into the first row and look for the first non-zero entry, we get an element 1 here. So what we need to do next is that we need to make other two elements or all other elements below that element, which we are calling pivot, because this is the first non-zero entry in the row, and every other element I have to make 0. So it means I have to make 2 0 and I have to make minus 2 0. So how that can be done? To do that, I can replace the second row by second row minus 2 times the first row. This is an elementary operation. And I can replace the third row by third row plus 2 times the first row. So what I will get? I will get a new matrix. I will get a new matrix, that is 1 3 5, and here I will get 0 and 0. And what I will get here? Minus 1 minus 3 into 2 6. So minus 1 minus 6 is minus 7, and 4 minus 5 into 10, so that is equal to minus 6. Okay. If I look at this third row, we are adding 2 times the first row. So 2 into 3 6 plus 8 is 14, and 5 into 2 10 plus 2 is equal to 12. So I am done with this part, that below the first non-zero entry in the first row, I have made every other element 0. Now I go into the second row and look for the first non-zero entry. So that we got is minus 7. Below minus 7, I have to make everything 0. So how that can be done? It is very clear that if I replace the third row R3 by R3 plus 2 times R2, I will get 0. So in this position, so I got 1 3 5 0 minus 7 minus 6 0 0 and 0. Now the matrix that I have got here is in echelon form. Why it is in echelon form? That there is a 0 row and it is coming in the bottom. So there is a 0 row and there is no non-zero row below it, means 0 rows should come in the bottom. If there are other rows, it should also come in the bottom. Second requirement is that first pivot here is coming in the first column, Next pivot, which is the first non-zero entry in the second row, is coming in the second column. So second column comes after the first column, so that requirement is also fulfilled. And there is no non-zero row above below the zero row, so this is in echelon form, so its rank is equal to 2 because there are two non-zero row, that is row 1 and row 2. This is a zero row, so its rank will be just 2 because we have got two non-zero row. I hope this is clear to you. Now let us find the rank of this matrix. So I am going to write here to save a space. So first of all, what should we do? Follow the same process. Go into the first row. So we go into the first row, we get a first non-zero element, that is 1. And I need to make everything in that column equal to 0. That is the process that we are following, fixing the first pivot element and making everything in that column equal to 0. So if I have to make this 0, what I can do, I can replace R2 by R2 minus 2 times R1. I can replace R3 by R3 minus R1, and I can replace R4 by R4 minus 5 times R1. So I got a new matrix. What? 1, 2, minus 3, 0, 0, 0. I already have reduced them in such a way that I got 0. Now 2 times the first row, so 2 into 2, and 1 minus 4, so 2 into 2 4, 1 minus 4 is minus 3. Here it is minus 1, and minus 2 into minus 3 is 6, so minus 1 and plus 6. So how much I will get? I will get let me repeat this for you. So what we are getting, minus 1 and plus 6, so I will get 5. And then what is the next term? That R3 minus R1, so 1 minus 1 already 0, minus 1 minus 2, this is minus 3, and 2 plus 3, that is equal to 5. Now go to the fourth row, so this is already 0, I have written. R4, so 4 minus 5 into 2, 10, so 4 minus 10 is minus 6, and minus 5 and plus 15 is equal to 10, right? So this is what we got. Now I go into the second row and fix the first non-zero element, which we can call the pivot element. Okay, and in that column I have to make everything 0. So what we can do to make this 0, I can simply replace the third row R3 by R3 minus R2, and I can replace the fourth row by R4 minus 2 times R2. So I got a new matrix here, 1, 2, minus 3, 0, minus 3, 5, 0, 0, 0, 0, 0, 0. Now this matrix is already in echelon form because there are two 0 rows, and 0 rows must be in the bottom. The first non-zero element or first pivot is coming in the first column, so the second pivot or second non-zero entry which is coming in the next row should come in a column after the first column. So this is coming in the second column, so it is satisfying the condition of the matrix to be in echelon form. So if I ask you how many non-zero rows are there, so there are two non-zero rows, so rank of this matrix is also equal to 2. I hope up to this it is clear. Now let me take one more example, because if we do lot of examples then we will be very clear about the process. So this is a 4 cross 4 matrix, right? And we have to find its rank. So what is the process? The process is that go into the first row, fix the first non-zero element. Now there is a possibility, suppose for the sake of argument, suppose this 1 is not there, there is a 0 here. So you will say that this is a this is a non-zero element. So in that case what we need to do, we need to do the row exchange. I will exchange R1 and R2, so I will get a 2 here and I will get a 0 here, right? So we should actually follow this strategy, that suppose we have a 0 element, in that case we will look down the column, and suppose for the sake of example this is 0, this is also 0, and this is also 0, then what we have to do, I will go down the last column, sorry, last row, means I will go down to the last element, and then it is a non-zero element, then I will do the row exchange, means in that case I will do R1 and R4 exchange. So that is what the process is. Now there is also a possibility that you may say that what if all the elements are 0 in that case. So if there is a possibility, if I say that this is 0, this is 0, this is also 0, this is also 0, and this is also 0. Suppose this is the first column. So in that case, if we go into the first row, we get a 0 here. Then we look down the column and we get all other elements also as 0. Then what we have to do? We have to go into the next element like 2, and after that we have to repeat the same process. I have to make this 0, this 0, and this 0. So this is an algorithmic approach. Most of the authors and most of the books also do not follow this algorithmic approach, and even in some of the standard textbook they are not following it, which is actually not the right approach, which is actually wrong, if I may say so, right? So let me do this calculation now. So I have fixed the first element and I have to make everything under that 0. So what I can do, I can replace R2 by R2 minus 2 times R1. I can replace R3 by R3 minus R1, and I can replace R4 by R4 minus 8 times R1, right? So if I do so, I will get a new matrix 1, 2, 3, 4, 0, 0, 0. 1 minus 2 into 2, 4 is equal to minus 3. 4 minus 6, that is minus 2. 5 minus 8, that is also equal to minus 3. R3 minus Y1, so 5 minus 2 is equal to 3. 5 minus 3 is equal to 2. 7 minus 4 is equal to 3. And if I go to the last, I think we need to write slightly better, otherwise the row and column thing will look confusing. So here it is 0, right? And we have the last element here. So now this is already 0. 1 minus 8 into 2, 16. So 1 minus 16 is minus 15. 14 minus 8 into 3, 24. So 14 minus 24 is minus 10. And 17 minus 8 into 4, 32. So that is equal to minus 15. So this is what we have got. Now I go into the second row, fix this element and make everything under that 0. So that can be done very easily. The third row can be replaced by third row plus second row, and the fourth row can be replaced by fourth row minus 5 times the second row. See, students also, and again I repeat, in lot of books and in lot of online resources also they make this mistake. They don't do this algorithmic thing, they do the random operation, which is not suitable, especially if you are trying to translate your process in terms of an algorithm, right? So if you come across someone who may suggest you that do this direct simple calculation, don't follow them. Follow what I am suggesting, means be very algorithmic in your approach. So I write 1, 2, 3, 4, and here I write 0, minus 3, minus 2, minus 3, and you can clearly see that if you add, it will become all 0. So the third row will become all 0, and fourth row will also become all 0 row. Now you can see that this is in echelon form because there are 2 0 rows, they are coming in the bottom. The first non-zero element is coming in the first row, is coming in the first column. In the second row, the first non-zero element is coming in the second column. So the second column comes after the first column. So this is in echelon form. So there are 2 non-zero rows. So rank of this matrix is equal to 2. I hope up to this the things are very much clear. Now I would suggest you that using this elementary row operation, find the rank of these 3 matrices, these 2 matrices, 5 problems which I am already done with. Now I am going to solve 2 very interesting problems, and these problems are very interesting, so make sure that you understand them properly. Now this is the question that find the value of mu for which the rank of this matrix is equal to 3. Now this is a 4 cross 4 matrix. Yes, ladies and gentlemen, this is a 4 cross 4 matrix. So if its rank is to be 3, means there should be a 3 cross 3 sub matrix whose determinant is not equal to 0. I repeat, there should be a 3 cross 3 submatrix whose determinant is not equal to 0, but the determinant of this matrix, if I call this matrix A, the determinant of the matrix A should be equal to 0. Because if determinant of A is not equal to 0, if determinant of A is not equal to 0, in that case its rank will be equal to 4. But it is already given that we have to find that value of mu for which its rank is 3, means this matrix should have the 0 determinant, right? So the first part is clear, that we have to find the value of determinant of this matrix, and then we have to equate that to 0. So let us do that. And this is a 4 cross 4 matrix. I already have discussed one such problem, that how to expand it to get the determinant. So let us expand this. Now you are all very mature, so you might be aware that to expand the determinant, if I expand it about the first row, it will be easier because we have two zeros here. So I am writing the expansion. Let me call this A, and I am writing determinant of A. So I am expanding it about the first row. So I fix the element mu. So mu, and I leave this row and I leave this column. So I will get mu minus 1, 0, 0, mu minus 1, 11 minus 6 and 1, right? Then I take minus 1. Minus 1 is coming in the first row, right? And second column. So first row plus second column means minus 1 to the power 3, that is equal to plus 1, right? So basically this is minus 1 and I have to write minus of minus 1, so it will become plus 1. So I am writing plus 1. I hope you got what I was trying to explain. So I have to leave this row and I have to leave this column. So I will be getting the value 0, minus 1 and 0. So 0, minus 1 and 0. Then 0, mu and minus 1. So 0, mu and minus 1. Then minus 6 and 1. So minus 6 and 1, right? Now I do the expansion further for this 3 cross 3 order determinant. So I take mu here. Again I expand it about the first row. So mu again, and mu into 1 is mu, and minus 6 into minus 1 is 6. So mu minus 6, right? And then minus plus 1, and 0 into 1 is 0, and 11 into minus 1 is minus 1. So minus plus, so this is plus 11. 0 will make everything 0, so no need to write. Now I expand the second one, so plus 1. And here if I expand about the first column or first row, no problem. I'm expanding it about the first column. So plus minus plus, right? So what it will be? It is 0, minus 1, 0. So let us expand it about the first row only, because expanding it about the row usually is more natural for us. So second, so it is minus 1. So it actually for this element we write minus. So minus plus, right? So this column is gone, this row is gone. So I will get what? I will get this column gone, this row gone. So 0 into 1 is 0, and minus 6 into minus 1 is 6. So I will get 0 minus 6. Okay. So what I got finally? I finally got mu into mu square minus 6 mu plus 11, and from there I am getting minus 6. So basically I am getting mu to the power 3 minus 6 mu square plus 11 mu minus 6. For rank to be equal to 3, the determinant of A should be equal to 0. So determinant of A 0 implies what? Mu cube minus 6 mu square plus 11 mu minus 6 is equal to 0. And this is a cubic polynomial. Do you know how to solve the cubic polynomial? To solve the cubic polynomial, I am going to use the hit and trial method. So to use hit and trial method, I am going to take the value, that is mu is equal to 1. So if I take mu is equal to 1, I will get 1 minus 6 plus 11 minus 6 is equal to 0. It means what? It means that mu minus 1 is a factor. there is a factor theorem which you have studied in your school. So mu minus 1 is a factor. Now I need to factorize this. So I hope you know there is something called division, so you can divide it by mu minus 1 and you will get a quadratic. But since I think you are all mature student now, so you can do the direct factorization also. So what you can do, you can write this as mu square common mu minus 1. So you see mu cube into mu square into mu will give you mu cube, and here you will get mu square minus 1, so minus mu square. But here you have minus 6 mu square, so you want to get minus 5 mu square extra, so you will write minus 5 mu and mu minus 1, because mu minus 1 is a factor, so I know that there will be a factor, so I can write directly. Now minus 5 mu and into minus 1, so I will get 5 mu, but I want 11 mu, means I want 6 mu more, so I can write 6 into mu minus 1. If you have understood this, fine, but otherwise you can directly divide. That is up to your convenience. So I can write mu minus 1 into mu square minus 5 mu plus 6 is equal to 0, and you can factorize it further, so it is mu minus 1, and if you factorize it, it will be mu as mu minus 2 into mu minus 3. I know how to, I hope you know how to factorize the quadratic equation, because mu square minus 5 mu plus 6 can be written as mu square minus 3 mu minus 2 mu plus 6. So you can write mu common mu minus 3 minus 2 common mu minus 3. So from there you will get mu minus 3 into mu minus 2. So I have written it. Right. So if I solve it, I get mu is equal to 1, 2 and 3. So the answer is, for find the value of mu for which the rank of this matrix is equal to 3. So there are 3 mu, that is 1, 2 and 3. Let us do one more interesting problem. And in this problem they are asking us to find the rank of this matrix. And rank of this matrix will depend on the value of P, Q and R. Right. So to solve this, because there are different cases, if like for example if I take P, Q and R all same, then it will have a different rank. If I take P, Q different, R different, then it will have a different rank. So how to answer this question? To answer this question, and this is interesting question, so I would suggest you that first you see the solution, and then I will repeat it in case if you do not follow it. So let's do it. So to do it, first of all I am going to write the expansion corresponding to this matrix, means I am going to calculate the determinant value of this matrix. So if I ask you calculate the determinant of A, so I write 1 1 1 P Q R, P to the power 3 Q to the power 3 and R to the power 3. This is equal to, you know the properties of determinant. What properties? That I want to get zeros in any of the rows or columns, so that expansion can be done easier. So I am making the row 2 and row 3, I am trying to get zeros in the first column. So will you allow me to replace the second row by second row minus P times the first row, and the third row R3 by R3 minus P to the power 3 times R1. So I will get 0 here, because 1 into P will be P, P minus P is 0, and 1 into P cube will be P cube minus P cube is equal to 0. This will be simply Q minus 1, sorry, Q minus P, because I am multiplying it by P. So this will be Q minus P, this will be R minus P, this will be Q to the power 3 minus P to the power 3, this will be R to the power 3 minus P to the power 3, right? So this is what we get. I hope up to this there is no doubt. Now I am going to expand it about the first column. So if I expand it about the first column, I take 1 and then Q minus P, R minus P, Q to the power 3 minus P to the power 3, R to the power 3 minus P to the power 3. I hope you remember a formula from your early childhood days. You have studied a formula that A cube minus B cube is equal to A minus B into A square plus AB plus B square. Do you remember this? So if you look at this here, we have a q minus p here, and we will have a factor of q minus p here also. So I can take q minus p common from the first column, and I can take r minus p common from the second column. So here I will get 1 1, and here I will get q square plus qp plus p square, and here I will get r square plus rp plus p square. Yes or no? Now I am going to expand it further. So I get q minus p into r minus p. And if I solve this determinant, I will get r square plus rp plus p square minus q square minus qp minus p square. Yes or no? Now this p square and this p square is cancelled. So I get what? I get q minus p into r minus p, and now I have to factorize this. So you can see that we have r square minus q square. So that can be written as r plus q into r minus q. And we have rp here and we have qp here. So from this I can take p common, and I will get r minus q. Now this r minus q is common in both this term, means I can take r minus q also common. So I get q minus p, r minus p, and r minus q, and what I get is r plus q plus p. So this basically is equal to, let me write it here. If you allow me to write, just for making it look better, I can write it in cyclic order. So it is q minus p and it is r minus q. So from this both I can take minus 1 common. So I will get p minus q, and from this I will get q minus r, and minus minus will make it plus, and this is r minus p, so I leave it as such, r minus p, and p plus q plus r. It is just to make it look better, otherwise you could have left it like this also. Now this is the value of the determinant. Now the next thing, the next part that I am going to highlight is going to be more important for you to understand. So let us take the different possibility, case 1. So case 1 that I am going to discuss, that when its rank will be 3, when the determinant of A is not equal to 0. And when the determinant of A will not be equal to 0, if P is not equal to Q and Q is also not equal to R, means P, Q and R should all be different. Then otherwise if any of them will be same, then any of this term will become 0. So they should all be different. And along with that, the P plus Q plus R should also not be equal to 0. Right? For example, if I say that P, Q and R are different, so suppose I take P is 1, Q is 2 and R is minus 3. So even though they are all distinct, but P plus Q plus R will become 0, which will make the determinant value 0. So its rank will not be equal to 3. So if this condition is satisfied, in this case the rank will be equal to 3. Now let us talk about what is the case 2. Case 2 is that when I say that P is not equal to Q is not equal to R, but it is possible that P plus Q plus R may be 0, like this example I already have taken. So in this case, since P, Q and R are not 0, we will have at least one 2 cross 2 submatrix whose determinant will not be equal to 0. Like if I say P and Q are not equal, then its determinant I will get is Q minus P, which is not equal to 0. So its rank will become 2. But since the whole determinant will become 0, so its rank can't be 3. So in that case, the rank will be equal to 2. Case 3. What will be the case 3? Case 3 will be that when we have exactly 2 of them are identical. Either I write it exactly 2 values of P, Q and R are identical. So in that case, if any of them, like if P or Q are equal, then it will become 0. So again the rank will be 2. If Q and R will be identical, this will become 0. Again the rank will be 2. If R and P are equal, then again it will become 0. The rank will be 2. And we will also be able to get a 2 cross 2. Like if I say P and Q are equal, but Q and R are not equal. So in that case, I am saying, suppose I am saying P and Q are equal. right? So this value will become 0. But since q and r are not equal, because I am saying exactly two of them are identical, in that case I will get a sub matrix like this, whose determinant like r minus q will not be equal to 0. So in that case also the rank will be equal to 2. And there is a fourth case also. I hope I don't have a space here, but I am trying to squeeze the things in between. The fourth case is that all of them are equal, like p is equal to q is equal to r. So in that case the rank will be equal to 1, because if you take p, q and r 0, not only the determinant will be 0, but any 2 cross 2 sub matrix will also be 0, right? Because if p and q are same, then q minus p will be 0, or if p and q are same, then if you take this sub matrix, q cube minus p cube will also be equal to 0. You can verify. It will be like a situation. Suppose for example, if I take all of them equal to 2, then all of them will be equal to 2. Then what will happen? I will get something like 1 1 1, 2 2 2, and 2 cube, 2 cube and 2 cube. It means that it will become its rank will become 1. Yes or no? So when all of them are equal to 3, then also its rank will become 1. So there are 4 possibility, and there is no other possibility. So I believe that you have understood. In case if you have not understood anything in this video, which is a very long video, but I wanted it to be very exhaustive and very clear in the concept. I believe that after watching this video you will be very clear about the concept. So make sure that you watch the video very with all the patience. Don't rush, and in case if you have watched the video, put your comments also, that what you have understood, what you have not understood, and share with everyone whom you know that are also taking this course. So thank you and have a great day.